Hi, Assalamualaikum. Um, in this video, I will continue the chapter 1 that we already start learning since week 1. So, in this video, I will explain more on the signal operations. There are actually mainly 3 operations that can be used to do some modification or call it transform the signal to be different function. So first is the reversal, second is scaling, third shifting, and the fourth one, addition and multiplication, is actually combination operation from the 3 operations before. And for the each operation, reversal, scaling and shifting, we can do based on time as well as amplitude. So if you want to do the operation based on time, the operation will affect the x-axis of the function, and if the amplitude, the operation will affect the y-axis values. So I will explain one by one based on the notes that I've been provided in the column. Okay. And first one is the time reversal, or what we call as time folding. So for example, we have this graph. This is actually ft, okay, and we want to reverse this function to be on the negative side. So what we can do is actually we mirrored it based on the time. Okay, but when we want to reverse, it's actually done on the y-axis, meaning that when you flip or fold this into a new function, it would be based on the y-axis, so that it will affect the time here. Okay, and if you want to do the reversal on the amplitude, okay, basically we have this function and we want to reverse this function to be on the amplitude, so it will become like this, and then the reversal is actually made on the x-axis here, so that you will get new function based on the amplitude. Okay, so that's on the reversal. Okay, and this is actually very useful when we learn later about impulse response, whereby the impulse response function d or delta negativity, we want it to be on the positive time domain, so we put it, or we can do this reversal operation to get the function that we wanted into the system. Next is the scaling. Scaling also can be done on the time base or amplitude base. So if it's on the time scaling, this in the yellow highlighted function is actually the basic equation, whereby the a over here can be more than 1 or less than 1. So if it's more than 1, if more than 1, okay, the signal become narrower and the operation is called compression. But if it's less than 1, the signal become wider, and that is called dilation. So for example, we have this function ft, and we want to scale it based on value of a. So if the value of a is more than 1, it will be compressed, and you can see that the function or the graph size shrink. But for less than 1, okay, it will be we call it wider, all right, like the function has been expanded to be this wide. Okay, that is for time scaling. I also provide some examples for you to understand better and do yourself during your free time, or maybe during our session in online classes. And for the amplitude scaling, all right, using the same equation, all right, in the yellow highlight line here, is actually based on a as well. So if it's actually more than 1, So you basically make it, expand it to be upward, and if less than 1 is make it a little bit downward or make it shrink. Okay, so that's for amplitude scaling. Okay, next is shifting. So shifting also we can do it based on time as well as amplitude. So if we shift it based on the time, we can put or add a constant using this common equation over here, and the t must be minus or plus a constant. Okay, so if you add a constant to a time, we call it as advanced signal, and if we decrease the time, we get the delayed signal. So this delayed and advanced signal is very, very important, especially when we do some operation using the Fourier series, Fourier transform, as well as Laplace. And then for example, here we have a signal that we want to make it delay because we decrease the time. So the original one is the black bold signal over here. So when we want to shift it to be delayed signal, it will be shifted into the right. Okay, but if we want to make it advanced signal, we add to a constant to the time, and the signal over here, all right, the shape of the signal will be shifted to the left. Okay, so that is for the time shifting. Alright, we also can do the time shifting in elementary signals, especially on the unit step and also ramp function. So if you don't know what is unit step or ramp function, please refer to my previous video. I already explained about this. Okay, and also how we can do the time shifting on once you can understand what is unit step and also ramp function. Okay, there are some examples for you to do as well. And for the time shifting over here, in example 8, actually there are methods that you can try to use, either of these three methods, to do the combination operations. For example, in example 8, we have this time a function that have scaling as well as the shifting. Okay, so how we can do that if we have this combination of operations? So in my notes, I provided 3 methods. So you can try to use any of them, and you will get the same answers. Okay. Right, next is amplitude shifting. So this is the command equation that you can use. So to the function, we need to add a constant. So if the constants we add it, so it will be upward. All right, and and if we deduct or increase the constant to the function, it will make it downward. Okay, so right, another more examples for you to do. Okay, and I try to explain more on this during my online class with you during the time that I have given private to us. So another one is the addition and multiplication. So if you see the question A and B here, basically is actually addition of 2 functions to be a different function y, and then you need to use combinations of 3 operations that you have learned before, scaling, shifting, as well as the reversal. Okay, so in the notes that I've given to you, I already provide a solution, but you need to understand for each step to get the answer how you can done that based on the explanation that I have given. So all these things I hope I can explain to you in detail in my class later on. Okay, so there are also example 12 that give questions based on the step unit. Okay, unit step function. So try to understand it and how you can use all the signal operation to answer the questions. Okay, so right, that's for signal operation. So I want to summarize all these signal operation before I enter the next subtopic, which is convolution. Okay, so I want to summarize what we have learned today in this video. So first we have reversal. Okay, and then second we have scaling. And then third one is the shifting. Okay, and we can make all this operation to be on the time or amplitude. Okay, so I just want to summarize it so that you can have bigger picture. Okay, so for this one, for reversal on the time, basically we will try to reverse. Okay, dalam bahasa Melayu kita sebut terbalik lah. Kita terbalikkan signal tu. Okay, to be on the time. So the function should be something like this. F for function minus t. Okay, and if you want to reverse the function to be on the amplitude, the common function should be negative function t. Okay, and for the scaling, all right, both for the time scaling, all right, we will have the common function to be yt f at. All right, and then for the amplitude scaling, you will get yt aft. Okay, the position of the A is different between time scaling and amplitude scaling. And for the shifting, all right, we have this yt equal to f t plus a or t minus a, depends. If you want the advanced signal is ft plus a, and if you want the delayed signal, it should be on the ft minus a. Okay, so it's plus minus over here. And then for the amplitude shifting, all right, it should be around here, ft, you plus minus a. Okay, so the position a is outside the bracket, but for the time shifting, the a position should be inside the bracket together with the time. Right, so what happened, or what is the name that we give when we have this type of operations? So for the reversal, basically we don't put any specific term for that, but for the time scaling, all right, if you have a more than 1, basically this is what we call as compression. Okay, and then if a less than 1, this is what we call dilation. All right, and for the scaling, all right, on the amplitude, okay, for the a over here, I think there is no specifically name given for the operation. Either you use more than 1, a is more than 1, or a less than 1. But for the shifting, especially on the time, yes, if you use t plus a, this is what we call advanced signal. Okay, and if t minus a, alright, this is what we call as delayed signal. Okay, so the values of the a is actually can be decided based on the either you use any amplifiers, the gain from the amplifiers, or maybe any filters that can make the function to be this either way of this. Okay, so another one, if you have for the shifting amplitude, you can make it either for the for the plus A, this is actually the function goes upward, and if minus A, this will go downward. Okay, so the function on the addition and multiplication operations, basically it can be done based on combination of these three operations. Okay, so I hope this can help you to understand better on the signal operations. Next video I will explain more on the convolution. Okay, alright, thank you for listening.